Hi everyone, this is Mrs. J, and today we're going to learn about geometric sequences and series. But first, I have a quick warm-up for you guys, so please pause the video and give it a try, and hit play when you're ready to check. Alright, go ahead and check your work here. So hopefully you notice the pattern. So for the first list of numbers, the pattern is that you multiply by 2 to get to the next term, so here would be the next 3. For part B, you're multiplying by -5 to get to the next term. So here would be the next 3 terms. And then for part C, you could word it differently. You could say that you're either multiplying by 1/2 or dividing by 2 to get to the next term. So it'd be 10, 5, and 5/2. All right, so in the last lesson, we talked about arithmetic sequences and series. So today we're talking about what are called geometric sequences and series. So a geometric sequence is a sequence where the terms have what's called a common ratio. So this essentially means that you are multiplying by the same number or value to get to the next term. So if you notice that a sequence is geometric, you can write an explicit rule using this formula. So the formula is a sub n equals a sub 1, which represents the first term in your sequence, times r, which is the common ratio, to the power of n minus 1. So notice here that only r is being raised to the power of n minus 1, not your first term. So we'll be using this formula today once we know that a sequence is in fact geometric. All right, so let's try these 3 problems together. So our goal again is to write the explicit rule, and then we're actually going to use that rule to find the 8th term of our sequence. So let's look at this first one to make sure it is geometric. So notice going from 4 to 12, we're multiplying by 3 times 3, and this is also times 3. So this is geometric. So our common ratio, which we use r, is 3. And we can see from our list that our first term, a sub 1, is 4. So now we can use our formula from the previous slide, which again is a sub 1 times r to the power of n minus 1. So here, a sub 1 is 4. So we say 4 times 3, which is our r value, to the power of n minus 1. Now, I know this looks like you should be able to simplify it more. I know you really, really want to multiply the 4 and the 3. However, you can't. 3 is being raised to the power of n minus 1. 4 is not. And according to order of operations, we should always do our exponents before we multiply. So you actually cannot multiply these. So again, this is absolutely not equal to 12 to the power of n minus 1. Okay, this is a big no-no. Do not multiply these terms. It's a PEMDAS violation. Okay, so this is actually what our final rule will look like. So now we can use this rule to find the 8th term, which would be, maybe a little bit easier than having to continue the pattern out to the 8th term. So again, we can say a sub 8 equals, so 4 times 3 to the power of 8 minus 1. So we're going to do 4 times 3 to the power of 7. So when you're calculating this, again, we need to make sure we're following order of operations. We do need to do 3 to the power of 7 first, and then we take that value and multiply it by 4. So the answer you should get for the 8th term is 8,748. So again, make sure you're following order of operations. We do 3 to the power of 7, and then we multiply that number by 4. I also would like to point out, if you plug this into your calculator just like you see it here, you should get the right answer because your calculator will always follow order of operations. So if you're typing it in carefully, you should be fine. All right, let's look at part B. So here again, let's check to make sure it is in fact geometric. So the difference from here to here, I know we could say divide by 2, but let's try to always use multiplication. So we're multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2. Then to get from here to here, it's times 1/2. To get from here to here, it's times 1/2. So this is a geometric sequence. And again, maybe your first instinct was to say -2. Maybe you said, oh, from here to here is -2. But if you look at the next step, it's -1. So you can see that it's not the same. So this is not arithmetic, it is geometric. So here our common ratio is 1/2. Our first term, a sub 1, is 4. So we can use that same formula. A sub n equals a sub 1 times r to the power of n minus 1. And again, this is how we will leave our answer. This is as much as you can simplify. So now let's use this to find the 8th term. So we do 4 times 1/2 to the power of 8 minus 1. So we do 4 times 1/2 to the power of 7. Again, just be careful to follow your order of operations. So rather than plugging this into our calculator for a decimal, let's actually evaluate it by hand so we can keep it as a fraction. So let's do this part first. So we have a sub 8 equals 4 times, well, 1 to the power of 7 is just 1. And then we can do 2 to the power of 7 for our denominator. And we get 128. So this right now is 4 over 128. Remember, when you're multiplying a whole number to a fraction, it only goes to the numerator. And then this fraction we can simplify if we divide the numerator and denominator by 4. So we end up with 1 over 32. And there you have it. Okay, let's try this last one. So here we are told that the common ratio of this sequence is 3, and we're told that the second term is 9. But we know for our formula, which you see over here, we need the common ratio and the first term. So there's a few different ways we can find the first term. So we don't know the first term, but we know that the second term is 9. Now, we can kind of use logic or work our way backwards. If we know the common ratio is 3, that means from the first term, we multiply by 3 to get to the second term. So if we work our way backwards and we divide by 3, we can figure out that our first term is 3. So that's one way to determine it. So again, we know that our common ratio is 3, and now we have our first term. However, there's a different way you can also find it, because what if we weren't given the second term? What if we were given the 50th term, and it'd be much harder to work our way backwards? So let's say we couldn't figure out, or we don't yet know what our first term is. Let's plug in what we know. So we don't know our a sub 1. We do know that r is 3 to the power of n minus 1. So you can see here that we are still trying to find a sub 1. So we can actually use this piece of information that we're given. We can actually substitute it into our rule to help us solve for a sub 1. So this is telling us that the second term is 9. So this says when n is 2, our term is 9. So we can replace a sub n with 9 equals, a sub 1 is what we're solving for, times 3 to the power of 2 minus 1. Remember, when we see this, it means the second term is 9. So when n is 2, our term is 9. And now we can simplify to solve for a sub 1. So here we get a sub 1 times, this is essentially just 3 to the power of 1, which is 3. And then if we divide both sides by 3, we get a sub 1 equals 3. So again, this is just a different way you can find the first term if you are not given it. Although we do need to know some piece of information about the sequence in order to do this. So again, now we know a sub 1, we know r, it was given, so our sequence is a sub n equals 3 times 3 to the power of n minus 1. And we can leave our answer like this. It's fine. Technically, we could multiply these two terms because they have the same base. but it is okay to leave our answer like this. But in case you are curious, this is just an alternative. You don't have to do this. This is 3 to the power of 1 times 3 to the power of n minus 1. So we're multiplying with the same base. Remember, our rule is to add up the exponents. So we have 3 to the power of 1 plus n minus 1. So we could technically simplify it to just 3 to the power of n. But of course, we can leave it like this and our explicit rule will work just as effectively. But since the base is the same here, it's kind of a rare case, we could technically multiply those two terms. But let's leave it like this and use this to find the 8th term. So we do 3 times 3 to the power of 8 minus 1, which is 3 times 3 to the power of 7. And so our 8th term should end up being 6,561. All right, so now we know how to write an explicit rule for a sequence, and we also know how to use that rule to help us find a term later on down the line. Okay, so go ahead and give these two a try. Please pause the video and we'll check your answers in just a few seconds. All right, go ahead and check these two problems. So for the first problem, our common ratio is 1/5. Our first term is 50, so we can create this sequence. And then to find the 10th term, again, we substitute n with 10, and we simplify. Here, you could get a decimal, but I just kept it as a fraction, so I raised 1/5 to the power of 9, and then multiplied by 50, and then you can simplify it to this fraction, 2 over 78,125. For part B, we're given the common ratio, but we need to find a sub 1. So remember, we can find a sub 1 kind of using logic and working backwards. If we know that the second term is 12 and we know that the common ratio is 1/4, working backwards by multiplying by 4, we would get 48. Or, again, we could do the process where we make the formula with the information we have, and then we substitute a sub n with 12 and n with 2, because our second term is 12. And then we would find a sub 1 and we get the same thing. So when you plug it into our formula, we get this. And then you can simplify it, and then we find the 10th term by replacing n with 10. And you can simplify this rather than getting a decimal. I guess a decimal is fine, but I think a fraction is a little better for these types of problems. All right, here's our last two examples for today. So here, now we're going to talk about some geometric series. So remember, a series is essentially just taking a sequence, a list of numbers, and instead of listing them with commas, we're now adding them up. So here's the sigma notation, which we reviewed in the last video. So if you need help with that, go watch my arithmetic sequences and series video again. So here we're going to expand the series and find the sum. So here's our rule, the explicit rule for this sequence. So it's a sub n equals -3 times 2 to the power of n minus 1. Remember, it's very common in sigma notation to use the variable I instead. And here they're asking us to find the sum of the first through 5th term. So the number on the bottom is the term to start with, and the number on top is this term to end with. So the first through 5th term. So that means we need to find the first through 5th terms. We're going to expand it out. So we do -3 times 2 to the power of 1 minus 1. Anything, so 2 to the power of 0, any number to the power of 0 is 1. Again, any number to the power of 0 is equal to 1. 1 times -3 is -3. Let's find the second term, so a sub 2. So it's -3 times 2 to the power of 2 minus 1. Replace n with 2. 2 to the power of 1 is 2. Times -3 is -6. For a sub 3, we have -3 times 2 to the power of 3 minus 1. 2 squared is 4. Times -3 is -12. Now let's find our fourth term. So 2 to the power of 3, 2 cubed is 8, times negative 3 is negative 24. And our fifth term, negative 3 times 2 to the power of 5 minus 1. So here, 2 to the power of 4 is 16, times negative 3 is negative 48. And so now that we have all of our terms, we can list them out to expand the series. So they're really just asking us to do negative 3 plus negative 6 plus negative 12 plus negative 24 plus negative 48. So this gives us an overall sum of negative 93. Okay, let's try one more together. So here in part B, again, we have our, this represents the explicit rule. So it's a sub n equals 32 times 1/2. Sorry, that was supposed to say minus. So to the power of n minus 1. And they would like us to find the sum of the third through fifth term. So this time we're starting with the third term. So let's find that. So 32 times 1/2 to the power of 3 minus 1. So 1/2 squared, 1/2 to the power of 2, is 1/4, which essentially just means 32 times 1 divided by 4, which is 8. Let's find the next term, the fourth term. So 32 times 1/2 to the power of 4 minus 1. So that's 32 times 1 over 8. 1 cubed is 1, 2 cubed is 8, and 32 divided by 8 is 4. That's our fourth term. And our fifth term, we have 32 times 1/2 to the power of 5 minus 1, which is 32 times 1 over 16. 2 to the power of 4 is 16, and 32 divided by 16 is 2. So now we have our third, fourth, and fifth terms. So we're doing 8 plus 4 plus 2. That's the expanded version of this sigma notation, and that gives us a sum of 14. All right, so that is all for today's video. Thank you guys for watching.